Hello students, welcome back. So now we are going to be talking about mean squared error, root mean squared error, mean absolute error, and mean absolute percentage error. So let's first understand a baseline model. Well, this one is a simple model, and this one acts as a reference. It kind of acts as a guidance. So this way we can determine whether the more complex model, the model that we are creating, whether is it an improvement or not. So an example of a base model would be something that predicts the mean of the target variable for all observation. So suppose you have this data right here, hours studied and scores, and you're trying to predict some type of model, and you create a baseline model. And the way you create a baseline model in this case is you take the mean of your target. So this is my score right here, and the mean of 5, 30, 20, 40, 60 comes out to be 31. So you say, okay, I have a baseline model, and this baseline model is going to make a prediction of the value 31. Every single value is going to be predicting 31. And then you try to create some model. And let's say this is the model you create right here. So let's say this model makes a prediction 7, 37, 24, 35, 53. Then you try to determine whether this model that you created, this one, is it better than your baseline model? That would be this one. So any model should give a better result than your baseline model. Now let's try to understand mean squared error first. Your mean squared error formula is given by this expression, and this one says that you take the actual value minus the predicted value, then you square the number, and then you add them all together. At the end, you divide by the total number of observation by n, and that will give you your mean squared error. So let's understand this through this example. This is my hours studied, this is the score the student obtained, and let's say my model makes a prediction. This is the equation it comes out with. So based on this equation, if the student studied for 1 hour, his y is going to be equal to minus 5 plus 12 times 1, based on this right here. And the answer will come out to be 7. Likewise, 19, 31, 43, 55 for each one of these hours studied. Okay, now we calculate our MSE. So MSE in this case is going to be equal to your actual score, which is 5 minus 7 square, plus 30 minus 19 square, this term right here, plus 20 minus 31 square, plus 40 minus 43 square, plus 60 minus 55 square, all the way up to here. And then at the end, you divide by 5. And the answer will come out to be 56. So this is my mean squared error for this particular model. And now let's compare our MSE with the baseline model. So this is my baseline model, and if you recall, my baseline model will have all the values as 31. 31 is the average value of these scores right here. So your baseline model, the MSE for the baseline model using this expression would be 5 minus 31 square, that will be this right here, 30 minus 31 square right here, that will be this right here, and likewise 20 minus 31 square, 40 minus 31 square, 60 minus 31 square, and then at the end you divide by 5, and the answer comes out to be 344. So this MSE tells me that my model, this one right here, it is doing a better job because because your MSE is a lot less over here compared with your MSE of your baseline model. So a few things I want to mention about MSE. The first one is that your unit is squared, so it can be hard to interpret. So for example, let's say your y, you're dealing with kilogram. So if your each unit is kilogram, then your MSE will come out to be kilogram square. So your numbers would be in kilogram square, and that can be a little bit hard to understand. Now your MSE is sensitive to large error, and that's because you're squaring your errors. These errors right here, you're squaring each term, and because of that, your errors, they become large. I mean, if you have one large error, this can actually affect your MSE. So in this case, your outliers, they can influence its value. Now, it penalizes large error more strongly because of the squaring I just explained to you. So if you want a model that cares a lot about outliers or big mistakes, you want to use MSE. This is a better option. Also, your MSE, they tend to be mathematically more convenient for, because you can differentiate them, and they tend to be smooth everywhere. That's why they are used. That's why they are very heavily used in gradient based optimization algorithms. And now root means squared error. Well, this is easy. You basically find your MSE first, and then you take a square root of that, and this will give you your RMSE. So in this case, this is my model right here. This is exactly the same model as the previous one. It makes this prediction right here. So first I calculate my MSE right here, And then I take my under root of MSE, and that will give me my root mean squared error, and the answer comes out to be 7.48. Now, a few things should be noted about the root mean squared error. First of all, is that it is in the same unit as your target variable. That's because after you square it, you're taking an under root. So if, let's say, every unit is in kilogram, then your RMSE will come out to be still in kilogram. So this way it is easy to interpret. Also, they tend to be robust to outlier because it's treating all errors linearly. So few extreme values, they are not going to affect your model big, like in a big way. And then you have mean absolute error. In this case, this is the expression for that. This basically saying that you take the difference between the actual value and the predicted value, and then you absolute that value. You basically just take these, you remove the sign and you just add them all together. And then at the end, you divide by the total number of observation. So suppose this is my model. This is exactly the same one as the previous one I showed you. So these are the prediction it's making. So in this case, my MAE would be equal to 5 minus 7 right here, and then take the absolute value plus 30 minus 19 right here, take the absolute value. 20 minus 31, take the absolute value, and likewise for this one and this one. And then at the end, you divide by 5, and your answer will come out to be 6.2. Now, your MAE in this case is going to be in the same unit as your target variable. If your target variable over here, let's say, is in kilogram or centimeter or meter, this will come out to be exactly in the same unit. And then you have mean absolute percentage error. This is the formula for mean absolute percentage error. Here, I'm taking the difference between the actual value and the predicted value, and then I'm dividing by the actual value. And then at the end, I take the absolute value. And then I add them all together, and you divide by the n, which is the total number of observation. So in this case, this is my data right here. This is the model that's making a prediction. So my MAPE in this case is going to be 1 over 5. That would be this expression right here. 1 over 5 times, you're saying 5 minus 7 divided by 5. This is my actual minus the predicted, divide by the actual value. So that would be this expression. Plus 30 minus 19 divided by 30. 30 minus 19 divided by 30. Likewise for the rest of the terms. And the last one was going to be 60 minus 55 divided by 60. That would be this minus this divided by this term. And then you divide by the whole thing by 5, and the answer will come out to be 0.295. In other words, 29.5. So the model prediction, the way you read mean absolute percentage error is this. The model's prediction, they are off by about 29.5% on average. Now, few things you want to consider when you are using MAPE. The first one is that your data should not contain 0. Well, that makes sense because you're dividing by your yi, this is your original data. So if your yi is 0, if you divide by 0, this is going to give you an error. This is not going to make sense. Also, all your values, they should be reasonably large. Well, that's because you're dividing by this number right here. If this number is very small, let's say it's 0.0001. So if you divide something by a very small number, this expression is going to get very big. So this will inflate your percentage error. Now, this is a little guideline you can use to interpret your MAPE percentage value. So let's say your MAPE value comes out to be less than 10%. Well, it means your model is very good. Predictions are very close to the actual values. If your MAPE value is between 10 and 20%, that means your model is good. On the other hand, if it's 20 to 50%, it's reasonably moderate. It has some noticeable error, but may still be usable. On the other hand, if your error is between 50 to 100% or greater than 100%, that means your model is poor. So your prediction are highly inaccurate.